Hello guys, welcome back to Manala's. So again, this is part 2 of the revision that we are having for the exam paper, for the grade 10 exam that you are writing soon, right? So now, in this situation, I just want to remove my blue light filter. In this situation, the topic that now we are focusing on is, I'm sure you've seen the topic, it is analytical geometry. Right, I'm sure it appears here on your screen. Now, in this situation, you first need to read the statement to the diagram. Make sure that every detail that is here on the diagram, on the statement, it matches what's on the diagram, right? So when that's the case, let's go through it. Where's my pen? I want the pen. Let's start with the highlighter. So here it says in the diagram below, PQRS. They're saying this is a kite. Now this is a bold statement. You being told that this is a kite, it's very important. And now they're saying P has these coordinates as we see them 3 and 5. S has these coordinates as we see them -1 and -4. They're saying PQ is equals to QR. So PQ is equals to QR and it's shown. And they're saying PS is equals to RS. Now that is not shown and I want us to highlight that. So I'm going to choose this red pen here. And I'm going to say this side is equals to that side because it's on the statement, right? Right, PS is equals to RS. Now, and they're saying Q is a point such that PQ is parallel to the x-axis. Okay, I see that. And they're saying PQ is equals to 5 units. Okay, let's put 5 units here. 5 units. Like I said, you want to make sure that everything that is in writing also appears on the diagram. And then they're saying that RQ is perpendicular. RQ is perpendicular, so I'll put a perpendicular sign here this way. RQ is perpendicular to the x-axis. The diagonals intersect at A, right? So since they told you that this is a kite, one aspect of a kite that's missing here, we know that this angle will be equals to that angle. We don't know yet whether we are going to use that, right? But we want to highlight it. So let me put 3 strokes here because I want to use the 2 strokes. And again, another property of a kite says this side here, AP is equals to this side here, AR. Right. So those are the extras we have to put on the diagram just because they said this is a kite. So everything about a kite, we want to put it on this diagram here. Now, this question doesn't really have 2 questions. It has multiple questions. So what I did, because this thing wouldn't fit on my screen, I broke it down into several questions like that, right? So I broke the question down into 4 slides. So this is this question has number 1 and number 2. This one has number 3 and number 4. This one has number 5 and number 6, and lastly this one has number 7, right? So that's how I did. I broke it down so that it fits on the slide here. Now let's go through the work. I want to use a black pen here. I feel like this is going to be very interesting. Let me remove this. The first question says here, show that coordinates of R are 8 and 0. Coordinates of R. Show that they are 8 and 0. Now, my way forward here, I would say that for 1.1, if the coordinate of R is I'm thinking about something. I'm just trying to find a way to express it. If coordinates of R are 8 and 0, then, right? Yeah, this is what I wanted to say. If coordinates of R are 8 and 0, then the distance of PS, you'll get into my mind soon. I just want to put my mind in writing. Distance of PS is equals to SR. That's what I want to say. Yeah. So I'm saying if the coordinates of this diagram here, they are 8 and 0 as we are supposed to prove them, then the distance of this side and this side must be the same. And if they are not the same, then it means this coordinate of r, it's not as we see it here, right? You might not understand that now, but let me show it to you. Right. So distance of PS, I'll substitute this with the distance formula. Now this is analytical geometry. Remember analytical geometry, we use three formulas: distance formula, gradient formula, and midpoint formula, right? So the distance of PS, I would find it by using the equation x at P minus x at S squared plus y at P minus y at S squared, right? That is what? That is the distance of PS. And then the distance of SR, that will be x at S minus x at R squared plus y at S minus y at R squared. That way, right? And then afterwards, you want to substitute then. Before you substitute, you want to write the coordinates you're talking about. Coordinates of P, you have 3 and 5. Coordinates of S, you have -1 and -4. Coordinates of R, you have 8 and 0. You are borrowing these things that you are proving. You are borrowing these coordinates here, the ones that you are proving, right? So we are going to use them here. And then we want to see if the left hand side will be equal to the right hand side. Now the left hand side is equal to the square root of what is x at P. X at P is 3 minus what is x at S. X at S, it is -1. So I'll put two brackets here, plus y at P. What is y at P? Y at P is 5 minus what is y at S. Y at S is -4. This way. Hope my writing is visible. Now that makes the left hand side to be equals to, let me take out my calculator quick. Now I just punched this on a calculator. As you can see here, this thing here gives me a value of √97, right? So √97 is the same as 9,85. Be good. Let me write that down. 9,85. Let's just use an eraser here. 9,85. Oops. My laptop crashed, guys. Let me see if I can get it back. So we got it back. And then what were we saying? We said the answer to this thing is 9,85. So let's put it here. Where's my pen? Oh, right here. 9,85 units. Let's choose a thinner pen. Right, you see that? And then I want to test the right hand side now. With the right hand side, I have to substitute in this formula here. So in which I'm going to say x at S. What is x at S? That is -1. And so that is x at S. X at S is -1 minus x at R. What is x at R? X at R is 8. I square that plus y at S. Y at S is -4 minus y at R. Y at R is 0. Square that, and all this is under a square root. And then my right hand side will be equals to, let me take out a calculator. And then with this one too, I'm also getting the same value. You see that all those values here, they're giving me √97, which is 9,85. 9,85. So I'll put 9,85 here. you're going to say therefore the left hand side is equals to the right hand side, which means coordinates of R are giving you 8 and 0. You see that? Proven. Now, you might have found this in a different way. This is my way. The memo might say something different, but this is my way of doing it. This is how I found it. But if you can use correct mathematical steps to get there, to prove this thing, then you are perfect. We good? If you have any questions, please talk to me. Now, the second question, let me clear up the space to answer the second question. The second question here says, write down the coordinates of A. All right. So where is A? Oh, here is A. Oh, and do you see what that does? Look at that. Look at how beautiful is that. This thing we said, let me choose a nice pen. We said if we use properties of, let me write that down. 1.2. 1.2, I'm going to say AP is equals to AR. Properties of a kite. Remember what we said, that one property of a kite that is missing here is to say this side is equals to this side here, because one diagonal of this diagonal of a kite bisects this diagonal, right? So now when that is the case, point A, it's the midpoint, it's where the bisecting happens. So since A is the midpoint, you can say therefore A is the midpoint. AP is equals to AR, therefore A is the midpoint. So now coordinates of A, we find them by the midpoint formula, in which the midpoint formula says I must take x at P plus x at R, divide them by 2, and then have y at P plus y at R, then also divide these ones by 2. Then I want to write the coordinates that I'm talking about. Coordinates of P, oops, let me charge my laptop. Where's the charger? There it is. Now, there we go. Yeah. So I was saying you want to write coordinates of P. Coordinates of P, you have 3 and 5. And then you want to write coordinates of R. Coordinates of R, we said you have 8 and 0. Right. Then you do your substitution. A has coordinates x at P is 3 plus x at R is 8 all over 2, and y at P is 5, y at R is 0, all this over 2. Now coordinates of A, that is giving you 11 over 2 and 5 over 2. There we go. Easy as that. Leave it as a fraction. Analytical geometry, we love fractions. We see that. Now, to save time, next question. Next question says, calculate the gradient of SQ. SQ. Now, here is one thing you need to understand about SQ. SQ, from this point here, from S to Q, the graph passes through A. So, which means if I can find the gradient of SA, then that is the same as the gradient of SQ, because these things are on the same line. So with that, I'm going to say gradient of SA is equals to the gradient of, you see, this is small letter m's. It's equals to the gradient of SQ, because we have collinear lines. These lines are collinear, right? Lines that are collinear are lines that are within the same line, right? So SA and SQ are on the same line. Now I'm looking for the gradient of SA, right? Gradient of SA, it means I'll have to find y at S, subtract y at A, all over x at S minus x at A. Now it doesn't end there. I need to write the coordinates I'm talking about. I have coordinate S, I have coordinate A. What is coordinate S? That is -1 and -4. What is coordinate A? I just found coordinate A on the previous question. 11 over 2 and 5 over 2. So let's write them here. I said I have 11 over 2 and 5 over 2. Right. So it might look like I need some, or I'll just put everything on a calculator. It's fine. So I'm going to say now my gradient of SA is equals to, what is y at S? Now you want to make sure that these things, when you do them, it's like you more or less cancel them. Y at S is -4. So I'm going to say -4 minus my y at A is 5 over 2. So I'm going to say 5 over 2. Right. And then I have my x at S. My x at S is -1 minus my x at A. My x at A is 11 over 2. Now, there are no points for, what do I want to say? There are no points for calculations here. This thing is just 3 marks. So which is most probably formula substitution answer. Right. Or if not formula, then 2 marks to substitution, 1 mark for answer. So here we have, boom, the following. When I punch this thing on a calculator directly, it gives me a gradient of +1. So I go there and I'm going to say gradient of SA is equals to +1. Easy as that. The gradient doesn't have units, remember that. Afterwards it says find the length of PR. Now that's 1.4. Hope you're still with me here. Let me save this thing so that it doesn't crash again. Let's wait for it. Perfect. Now gradient of PR. Gradient of PR. Let's look at PR. Now we know that this is a kite, right? Ooh, look at how beautiful is that. So we know that. Let me do this. Let me do this quick. Navigating this thing today, it's quite a challenge, but it's okay. What I'm saying is that the line AQ is perpendicular to the line PR. Why? These are properties of a kite. Right? Properties of a kite, I'm not sure if I said it in the previous point. Oh, I didn't. But properties of a kite are saying that the diagonals will meet at the right angles. That's one thing for sure. Okay? So if that is the case, it means now the gradient of AQ multiplied by the gradient of PR is equals to -1, right? So I'm going to put a therefore symbol here, which means now in this situation, if the gradient of SA, right, is equals to it's equals to 1, it means now the gradient of PR will be equals to -1. Now some of you might be lost at, sorry, say, what do you mean there? If you are lost, don't worry, I'm going to do it again now, step by step through calculation. Now what I'm saying is that we already found the gradient of SQ, right? This is 1.4. I'm answering 1.4. We said the gradient of SQ is equals to 1. That's what we found, right? And then now, through properties of a kite, we know that diagonals meet at 90-degree angles. So I'm saying now PR is perpendicular to AQ. Why? Because these are properties of a kite, right? This diagonal here, this diagonal here, and this diagonal here, they're meeting here at 90-degree angle because that's a property of a kite. So which means now the gradient of the line PR multiplied by the gradient of the line AQ must give me -1. Let me put a therefore symbol here so it makes sense, right? And then what is the gradient of PR? Okay, no. What is the gradient of AQ? I know that the gradient of AQ is equals to the gradient of SQ, which is 1. Why? Because the line are collinear lines. So I'm saying this line SQ, the whole line SQ, has the same gradient as the line AQ. It makes sense because these are on the same line, right? So which means this formula here, this formula, I can substitute it by saying the gradient of PR multiplied by the gradient of SQ is equals to -1. Now the gradient of SQ, I already have it. I can substitute it here. Gradient of PR multiplied by, what is the gradient of SQ? That is 1. So multiplied by 1 is equals to -1. Now what is this times 1? When you multiply anything by 1, it doesn't change. It means now the gradient of PR is equals to -1, which is what they wanted here. This is the longer version of this answer here. I made it the longer version because I somehow wanted you to understand it. We good? Now, on to the next question. If you hear any background noise, please do not be surprised, guys. It's raining here. So here we have this question. It says, calculate the area of the kite PQRS. Area of the kite PQRS. Now, I'm not going to do the whole area here. I'm trying to save time. But I am going to show you how you find it. And after I showed you, trust me, you will be able to find it. Right? So, now this area of a kite, there are two ways to calculate this area. And I'm trying to think of the shortest way. So the area of this thing, it says, let me put a pen here. Area of a kite, this is 1.5, right? Area of a kite, this is how you find it. For this area, you must say half multiplied by the first diagonal and the second diagonal. So half times the first diagonal times the second diagonal. So we'll call SQ diagonal number 1. That will be diagonal number 1. And we will call PR diagonal number 2. Right. So what does that mean? That means now we must have the distance for PR and the distance for SQ for us to be able to calculate this. It's going to take us some time, and I hate the fact that it's going to take us some time. So now let's start here. For PR, you need coordinates of P and coordinates of R, but we found coordinates of R. It was said to be 8 and 0. I hope you still remember that, right? So for SQ, you need coordinates of Q. However, if they said this line here, PQ, remember what they said about PQ? They said PQ is parallel to the x-axis, which means PQ is directly parallel to this line here, right? I'm coming to that. Which means now, if that, okay, let me do it now. If PQ is parallel to the x-axis, it means whatever value it is here, whatever value we have here, it will move straight and match the value at Q. So let's do that. It says now the y value here, it's going to match the y value here and the y value there. So the y value here is 5, which means here it will be 5, and here it will also be 5, right? Another thing that they said RQ is perpendicular to the x-axis, which means RQ is perpendicular to the x-axis, meaning it's parallel to the y-axis, which means our x value here is going to match the x value here at Q. Our x value here was 8, it means the x value here is 8. So which means now coordinates of Q, we have 8 and 5, right? So now you can calculate the distance of SQ, and then you can calculate the distance of PR, and then multiply them together, divide them by 2, like substitute into this formula. After you get the distances, then you will have your area, how much it is. We good? I don't think that will be a problem for you. Just use the distance formula here to find SQ, use the distance formula here to find PR, and then see how much you get for area. I'm not sure if this question forward, it will need me to have those values. If it ever does need me to have those values, I will come back for them. Right. Now 1.6, it says show that PR is perpendicular to SQ. Now we've already proven that, but to give them something more convincing, I don't know why did they set this exam this way, but to be honest, in our steps to finding the solutions they wanted, we've already proven easily by properties of a kite that PR is perpendicular to SQ. But then that's not a problem. We can still do it again. And I'm not going to do the whole thing of it again. I'm going to show you how to do it. No, in fact, you know what? Let me do it. We are saying here, for you to prove that, we're going to say if PR is perpendicular to SQ, then the gradient of PR multiplied by the gradient of SQ will be equals to -1. You see that? Which means now we have to find the gradient of PR. So that is y at P minus y at R all over x at P minus x at R. I need to write those coordinates here now. P and R. What are the coordinates for P? That is 3 and 5. What are the coordinates for R? That is 8 and 0. This way. Now I do my substitution. X at P is how much? That is y at P is 5 minus y at R is 0. X at P is how much? That is 3 minus x at R is 8. That gives me 5 over -5, and that is -1. This way. Did I find the gradient of PR? Oh yes, I did find the gradient of PR. The gradient of PR, I found it to be -1, and the gradient of SQ, let me come here. The gradient of SQ, I did find it to be 1. Oh, easy. I shouldn't have calculated that. So which means here I can easily say gradient of PR is equals to, we said gradient of PR is equals to -1, and gradient of SQ is equals to 1. Our reason is that this is already proven. I don't need all the step. It's correct, but I don't need it, right? So then I'm going to say, sorry, what I don't need is this one. Why do I make these mistakes? Let's do this. What I don't need is this part here, this part. Boom. It's not wrong. It's just a long step. It's not needed. So I'm saying if the gradient of PR is if PR is perpendicular to SQ, then the gradient of PR multiplied by the gradient of SQ is equals to -1. So afterwards, I'm saying gradient of PR is equals to -1 and the gradient of SQ is equals to 1 because this is proven. I'm going to say therefore -1 times 1 is equals to -1. Conclusion: PR is perpendicular to SQ. Our reason is that the gradient of PR multiplied by the gradient of SQ was equals to -1. This way. Right. So our answer is here. Our answer is this way. Our answer is that if PR is perpendicular to SQ, then the gradient of PR multiplied by the gradient of SQ will be equals to -1. And then we come to the step where we say gradient of PR is equals to -1 and the gradient of SQ is equals to 1 because this is already proven in the previous questions. Therefore, I showed them, I'm saying this gradient times this gradient, that gives me -1. Therefore, PR is perpendicular to SQ. Proven. Right. So that's hence I'm saying they didn't have to ask this question because we already proved it. We see that. I feel like they didn't have to ask this question because in our way to getting our answers, we proved it. Maybe they thought their memo in a different way. That's why. Now the last question. The last question says show that triangle PSR is an isosceles triangle. Now, here's another problem. We already proved this thing. And I'm going to show you how we already proved it. And I'm going to show you what to write, but we already did this. So, if I'm answering this question, right? I'm already answering here. if triangle PSR is an isosceles triangle, then PS is equals to SR. Be good? So I'm going to say PS is equals to, let's go look for it. I did it somewhere. Didn't I do it? I think it was the first question. Yeah, it's here. I just removed it, but I did PS, and then I found out that it was 9,85. I hope you still remember that. And I did this part here, and I also remember, and I also found out that this is equals to 9,85, right? I hope you remember that. So PS is equals to 9,85, proven. And then I'm going to say SR is equals to 9,85, proven. I'm going to say therefore PS is equals to SR, which means triangle PSR is an isosceles triangle. Now, if you haven't went through the step when you're proving it, if it's not proven for you, then I'm sorry, you will just have to take the long route. That's what you will have to do. And there's nothing wrong with that. There is absolutely nothing wrong. You're going to find the distance of SP, right, through the distance formula by saying x at S minus x at P all squared plus y at S minus y at P all squared, right? See how much you get. Afterwards, you're going to find the distance formula for SR by saying x at S minus x at R squared plus y at S minus y at R, and then square it, and see how much you get there. The distance you get here on this answer here should be the same as the distance you get here. Then afterwards, you're going to say PS is equal to SR, which means this triangle is an isosceles, and then you get your 4 marks. It's as easy as that, guys. So this is the end of this video for analytical geometry. This was an easy question. I never thought it would be this easy when I was choosing it, but then I hope you got it right. And if you didn't, please make sure you understand my explanation on this. And if you have any questions, please comment on this video or inbox me if you are able to inbox me, if you have my details, so to say, right? So again, guys, if you haven't subscribed to the channel, please don't forget to subscribe. And I don't have much to say. Don't forget to like the video and share to people you know who are going to need this. Goodbye for now. See you on the next video.